We're now recording. So this is the AP study group on Thursday, April 22nd, the 12 to 1 o'clock session. We're covering multiple choice non-calc, working on the pale lavender packet. More specifically, working on the 15 sample problems near the end of that packet. I'm going to cover numbers 1 through 5 before we go into breakout rooms. So for number 1, the graphs of the functions f and g are shown above. The value of the limit as x approaches 1 of f of g of x. Well, if we think about it, you don't really have, obviously, functions for g or f, right? But x is approaching 1. So you could really kind of do this first to see what that limit's going to be. And we know what that limit's going to be. That limit's going to be 2. Yes, g of 1 equals 1. Absolutely. But we're not asking about what y equals at x. We're asking about approach, right? And it is a composite function. It looks a little weird. We didn't quite do that last semester. But if you just use a little intuition, you know, usually when you evaluate a composite function, you start at the inside, right? So why not start the limit at the inside? So we get 2. Then what you're going to do is you're going to take the limit as x approaches 2 of f of x. Then you do the outside second. And of course, that's pretty obvious. That's 3. So the answer is C for number 1. That's all you have to do. Again, you're going to be sometimes throwing some curveballs. We got thrown a curveball here, but you know, we stayed calm. We did what we know about composite functions. And we saw, okay, that's 2. And now x approaches 2 for f of x. And so we get 3. So that's number 1. That's how I'd approach that one. Moving right along, let's look at number 2. Here we got a funky limit problem. Now, for those who did A and B period and did some of those leftover topics in AP study groups, we covered something called Hopitals Rule. Now, for those who are in D period, you probably have no idea what I'm talking about, but it's okay. It's a pretty easy rule. Hopitals Rule comes from section 9.3. It's the last section of our curriculum. But before I get to it, usually when you have a limit, you should plug in what x is approaching. So you get 0 minus sine 0 over 0 squared plus sine 0, which of course is 0 over 0. It's indeterminate. So that's where you don't put your hands up and give up. What you do, you got to get creative. Now, you could do some creative algebra if you want. We did do that again in the fall semester. But there's another rule called Leoptol's rule. Because question in the chat. Oh, sorry. We're on the pale lavender. We're near the end. We're the one that's called 15 sample problems 2017 multiple choice. It's probably like the 1, 2, 3, 4, the 6th to last page, I believe, or 7th to last page. No, 6th to last page. So it's called 15. Let me scroll up again. It's called 15 sample problems 26 after 2012. Just say that. You're welcome. Okay. So anyway, there's a rule called Leoptol's rule. You can use this rule when you have 0 over 0 happening when you evaluate a limit. What is Leoptol's rule? What you do is you take the derivative of both numerator and denominator separately. And then you evaluate the limit at whatever x is approaching and see if you can actually get an answer. If you still get 0 over 0, then you do it again. You take the derivative again until you make it work. So let's do it. If I take my derivative, I get 7 minus cos x over 2x, and there's a chain rule here, 3 cos 3x. Okay, now I'm going to plug in 0. That's 7 minus cos 0 over 2 times 0. Sorry, I missed a little messy there. Let me make that a little neater. Okay. Plus 3 cos 0. Well, you should know that cos 0 is 1. So 7 minus 1 over 0 plus 3. So you get 6 over 3. And you get 2. The answer is B. So Leoptol's rule was around on the AP exam when I took the AP exam over 20 years ago. Then it got rid of it, then it brought it back a few years ago. I'm actually glad they brought it back because I think it's a really cool rule to use. So that's all. And you want to look for that. When you see a very funky limit and you plug in what x approaching at 0 over 0, that's what you're going to do. Okay, we're gonna keep moving because I want to make sure we get to a breakout room in the next few minutes. Here we got a derivative, sine natural log of 2x, okay? So it's gonna be a chain rule. In fact, actually it's a double chain rule. It's a double chain rule. So you take to the derivative of the outside, which is cosine, keep the inside intact. Then I change colors. Then you do the derivative of the inside here, which is, and actually I'll just write like this for now. Okay, so this is the beginning of chain rule. Excuse me. So you have cosine natural log 2x times 1 over 2x. Great. However, you still have another chain rule. You got the 2x part. You got to take care of that as well. This is the one beauty about Zoom is that, you know, instead of doing this in person, I can easily change colors up. I mean, yes, you can do different color markers, but kind of like that on Zoom. Times 2. Cool. Now we just do a little canceling if we can. So it's basically cosine natural log 2x all over x. And that's why I like B. B would be the correct answer for that one. Okay. We'll keep moving. For number 4, they're asking you one graph is f, one graph is f prime, one is f double prime. Which of the following correctly identified each of these 3 graphs? So it's a little tricky. What you're going to want to do is look at tangent lines first, or horizontal tangent lines. You might remember that little demonstration we did. We had draw the tangent. So I draw the derivative from original graph and I look at tangent lines. So I would probably look at horizontal tangents first. That might help as a strategy. So for example, what if 1 were the original graph? Then I have horizontal tangent at like 1.5 and like this is 2, 3, 4, and probably like 4.5. So it means I should be the f prime graph should be crossing the x-axis at 1.5, 4.5, which kind of does for 3, but with 1 being the original graph, they said 2 was f prime, so that doesn't work for us, and I don't see another choice with 1 as f. So let's look at 2 being original graph. You have horizontal tangent at 0, 1 point something, just 2, 3, 4, and 4 point something. Now, that looks pretty good with 3 being f prime. If this is f, it looks pretty good because I do have x-intercepts at where I have the horizontal tangents for the original graph. Remember, the x-intercepts f prime are the horizontal tangents on the original graph. And then if I do the horizontal tangents here, which happen at like, you know, 0.5 maybe, and maybe around like 3 or so, I see the x-intercepts here. So this is f prime, this is f double prime. So using a little process elimination, I get 2, 3, 1. The answer is C. Another thing that you guys should know, which I'm assuming not many people have done SAT or ACT because of all the cancellations, but if you have done test prep, one phrase the College Board loves to use is which of the following, blah, 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 even the ACT as well. That's going to imply a process of elimination technique. So instantly you should be in that frame of mind when you see which of the following, blah, blah, blah. You instantly want to kind of start looking at the choices because that kind of helped me in getting the answer. Otherwise, you're going to drive yourself a little nuts and trying to figure out like which one's f prime. But the strategy of drawing horizontal tangents helps some for sure. Okay, number 5, then we're going to breakout rooms. And then you guys are going to do 6 through 15 in this set here. And just so you know, on the AP exam, really quick, if I show you the national exam info, you know, the part where you do bold choice without a calculator, where calculator is not permitted, it's 30 questions, 60 minutes. So you get an average of 2 minutes per question. So naturally, I would do this faster because I do this for a living. But you know, I'm just trying to show you the process, right? Because you guys will probably need about 2 minutes per question. And of course, I'm explaining everything. No, someone's asked about D period. No, it's okay. Just do what you can. Because I think some of these you could do. Because remember, you guys have done the fall semester. You've done at least 6 topics for this semester. Yes, there's some stuff you won't be able to do, and you'll have to skip over them. That's okay. Just do what you can. But don't worry, for D period, I'm going to give you the same thing after we finish session 4 in late May. You guys will still get the same thing. But it's good you're here anyway because you're getting extra practice. Okay, number 5, really quickly. The local linear approximation. So this is a kind of a weird one. We didn't cover this for A or B period during the normal session. We did cover the leftover topics. This is section 5.5, by the way. So what does this mean? All it just means is they want a tangent line. That's all it means. Just give me a tangent line. So you have, so they give you the tangent line actually. It's y equals 4x plus 1. And they say that it's done at x equals 1/2. So when they ask for this, what they're asking for is for you to plug 1/2 into the function. So I'm going to plug 1/2. So when they do g of 1/2, let's plug 1/2 into the tangent line itself. Because what's happening, we have a linear approximation. You have a funky curve, and then you have a tangent line. And the tangent line and the curve, wherever they touch, if you choose some x values close to the point of tangency, it's going to be a good approximation of the red curve. That's why I call it linear approximation. So you could just plug 1/2 into your original function. Sorry, plug 1/2 into your tangent line, which is kind of like plugging into the original function. And that'll be 3. Then for g prime 1/2, that's just going to be the slope of the tangent line. Well, what's the slope of the tangent line? Of course, 4. 3 plus 4 is 7. So the answer is D for that one. So for those who've seen this process, you know the concept, but it was a little weird the way they asked it. Okay. So now you guys are going to do 6 through 15. Just going to give you a heads up. 6 should be fine. You guys should know how to do acceleration, derivative, velocity. 7 is going to be interpreting a derivative, which you guys should be comfortable with. 8's a doozy. You may want to skip 8. I'll help you with that when I hop into the breakout rooms. 9 should be, that's more second semester integral stuff. 10's integral stuff. 11, that's also going to be an integral, I believe. Yes. 12 is an integral. 13 is differential equations. 14 is about continuity. And 15 is about derivative inverse functions. So for D period, the problems that you probably would want to focus on would be 14 and 15. And probably 6 and 7. So at least try those. If you feel, okay, yeah, I got those done, I know obviously can't do the other ones, you can move ahead and work on the 10th sample, because we're also going to work on the end of the packet, the 10 more sample questions. We're going to do that as well. So there's 10 questions. You get an average of 2 minutes per question. We're going to do this for about 20-minute breakout sessions. 12:20, 12:20, 12:40. We'll come back. I'll have the answers for these for you. And then we'll do the other packet, the 10 sample problems. So let's do the breakout rooms right now. I'll stop.